So a partition is a cut or a break. In this video, I'm going to teach you how to find a point that partitions a segment into a certain ratio. So in other words, we're finding a point that will split the segment into a certain ratio. Okay, the first thing we need to do is figure out the fraction that will tell us how far to go from point A or how far to go from point B to split the segment in the ratio that we want. A directed line segment means that the order of the endpoints matters. So AB means from A to B. So that matters because when we talk about the ratio of 3 to 2, the 3 is associated with the A and the 2 is associated with the B. If this had said BA, then the 3 would have been for the B and the 2 would have been for the A. But it's AB, so I have 3 to 2 is A to B. Now, you have to consider that if we are 3 spaces away from A, for every 2 spaces that we are away from B, what's the total number of spaces in that small model? Well, that's a total of 5. So we're going to use these 3 numbers to come up with the fractions. So the first fraction is going to be 3 over 5, 3/5, okay, because our partition, our split, is going to be 3/5 of the way from A. Okay, see what I mean by the 3 goes with the A? That's why the 3/5 means we're gonna go 3/5 of the way from A, and then we'll make our partition. Or we could do 2/5 from B. Okay, maybe I'll put it underneath. So, or we can go 2/5 from B. Okay, those are the 2 choices that we have. Because we are given ordered pairs like 3, 4 and 6, 10, this tells me that we are dealing with x's and y's. So what you want to do is deal with the x's separately from the y's. So on the left side, I'm going to work out a diagram for the x values. Okay, so I'll figure out how far from A I'm going to have to go just by looking at the x values. And then separately, I will do the y values. All right, and then at the end, I'll put the 2 together to get an ordered pair using the x value partition and the y value partition. Okay, so first, focus your eyes on the x values. Let's make ourselves a little number line. So, AB, okay, so here comes my number line. All right, remember, right now, this is x values, and then this will be y values. Okay, so for x values, I have 3 and 6. Okay, so I'm going to put the 3 here and the 6 here. I always put them in order from least to greatest. So that means this 3 is A, and the 6 is the B. Okay, now over here I'm going to have the y values. The y values are 4 and 10. Okay, so that's 4 and 10, and this will be the A, and this will be the B. All right, so that's my drawing. Now the next thing I need to know is what is the distance between A and B from 3 to 6? Well, of course, those are 3 apart. Now, what is the distance from 4 to 10? Okay, these are 6 apart. Now, here's where the fractions come in. So, for the for the partition in both cases, I'm going to go 3/5 of the way from A. So 3 is the length of the entire way. So, but I need to go 3/5 of the way. So that means I need to go 3/5 of 3. Okay, so that's interesting because this is going to be a decimal. Okay, but we'll just have to deal with that. So this tells us how far away from A we're going to go. By the way, I could have gone from B if I wanted to and used 2/5. But I usually, given a choice, I will just always go from left to right. So that's why I'm picking A and I'm going with the 3/5. Now, what is this? You know, this is going to be whatever 9 divided by 5 is. Let me slide this over for a second. Okay, so I'm just going to go ahead and find this decimal. So 3/5 of 3. Okay, well, it's just 9/5. Okay, I'm going to go ahead and turn this into a decimal. So that's 1.8. Okay, so this is 1.8. So this tells me that I need to go 1.8 from A. Okay, so I'm going from A, and I'm going to move 1.8 because it's 3/5 from A, and that's 1.8. So that means I need to add 1.8. So where do I land? What's 3 plus 1.8? That's going to be 4.8. So kabam, that is the X value. It's just that easy. All right, so now we need to turn around and do the Y value in the same way. Okay, so I'm still going to go from left to right, so I'm still going to do the 3/5. All right, so this time I'm doing 3/5 of 6 to figure out how far I need to go. All right, so 3/5 of 6, okay, is 18/5, or 3.6. So that is 3.6. So that tells me how far from A I need to go. All right, 3/5 away from A is 3.6. So I'm going to go 3.6 away. So that means I'm adding 3.6. So what is 4 plus 3.6? That is 7.6. Okay, so I've now found the X value and the Y value of my partition. So that means that the final answer, if I can almost squeeze this in here, I'll just put the final answer right here next to it. The final answer is going to be 4.8, comma 7.6. Okay, this will be the point that splits the segment into a ratio of 3:2. Let's do a quick diagram just to show you what we just did. I feel like because there's no picture, you probably don't have a feel for what we're doing. You might be able to solve the problem, but you don't really know what you're solving. So let's draw it. The point A is at 3, 4. Okay, so that would be like, okay, so this would be 3, 4. So this is the point A. And then the point B is at 6, 10. All right, so here's 6, 10 would be right here. So this is point B. All right, so here is the original segment, all right, from A to B. Now, we were supposed to partition or split this segment so that it will have the ratio of 3:2. All right, so that means the A part should be a little bit bigger than the B part. All right, 3:2. The A part is bigger than the B part. So we came up with a point 4.8, 7.6. Okay. So 4.8, all right, so this would be 4.5 right here. So 4.8 is just going to be a little bit past this. And 7.6. Okay, so this is 7, 7.5. Okay, so that's going to be right about here. All right, so this is that point that we found, the 4.8, comma 7.6. And notice how this splits up the segment into two parts where this portion is a little bit bigger than this portion. And if we looked at these lengths, this would turn out to have the ratio of 3 to 2. So that's what we just did. Okay, let's do that one more time. Problem number 10 is the same as problem number 9. The only thing that changed is the order of the endpoints for the directed line segment. So instead of AB, it is now BA. That's the only change. Let's see how that changes the mathematics in the problem. All right, let's start with creating those fractions like we did last time. So here's the big change. Because we're dealing with segment BA, that means the B is going to be associated with the 3, and the A is going to be associated with the 2. Now the total of these is 5, so that's where I'm going to get the fractions 3/5 and 2/5. Now those fractions tell me that when I find the point that partitions or splits the segment in the ratio 3 to 2, that point will be 3/5 of the way from B, or that point will be 2/5 of the way from A. Okay, so the order of the letters tell me which fraction pertains to which endpoint. So now the rest of the problem is going to be the same, but we're obviously going to end up with a different point. So we still have x's and y's, so that means I need to make separate diagrams. So I'm going to work out the x values over here on the left, and I'm going to work out the y values over here on the right. Okay, so here is my little number line representing the x values, and this will be my little number line representing the y values. So as before, the x values are 3 and 6. So there's my 3 and my 6, and that is A and B. And my y values are still 4 and 10. So this will be 4 and 10, and that's still A and B. All of that is the same. Okay, we're going to go 3/5 of the way from B or 2/5 of the way from A. So we need to know how long the whole way is. So just like last time, from 3 to 6, that is a distance of 3. And from 4 to 10, that is a distance of 6. So I always like to imagine moving from left to right when I do these problems. So I'm going to calculate the distance from A just because it happens to be on the left. So that's why I'm going to use 2/5, because I know I need to go 2/5 of the way from A. Okay, so that's why I'm going to multiply by 2/5. All right, so I can find out how far 2/5 of the way is. So what is 2/5 times 3? Okay, so 2/5 times 3, that's 1.2. Okay, so that tells me how far to go from A. So I'm going to go 1.2 away. All right, so if I'm going 1.2 to the right, that means I'm adding 1.2. 3 plus 1.2 is 4.2. So that's going to be the x value of the partition point. let's do the same thing with the y values. I'm still going to go from A just because it's on the left. So I'm still going to do 2/5 of the way. So 2/5 times 6. All right, but let's find out how far that is. So 2/5 of 6 is 2.4. So that tells me how far to go from A. So I'm going to start at A and I'm going to go 2.4. So that means plus 2.4. So 4 plus 2.4 is 6.4. So this will be the y value of my partition point. If I put those together, and did they tell us what they told us to call it point P. So I'm going to put point P is the point 4.2 comma 6.4. All right, so this is the point P that splits segment BA into the ratio of 3:2, where the distance from B is a little bit bigger than the distance from A. All right, and just looking back at the previous problem, I should have called this point P as well. So I think I'll just make that last minute change and call it point P. All right, anyway, that is how it's done. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.